Hi folks, we'll get started in just a second. Okay, so welcome to this Google Hangout on Air, which is a little bit interesting. But we're going to talk today about how to learn data science. So this is a pretty broad topic. And if you have questions along the way, there is a questions box where you can submit your own questions and queries. So we'll just wait a couple of seconds for other people. Okay, so my name's Vic. I'm the founder of DataQuest, and if you have any questions after this Google Hangout, you can feel free to email me at the address you see below. So let me just full screen this real quick. Okay. Actually, all right. So before I get started, what is DataQuest? So DataQuest is a site that features in-browser data science tutorials. And we focus heavily on learning theory and application together, not just one or the other. So what this means is that you learn things from the fundamentals, from the ground up, before you implement them. And as we'll see throughout this presentation, what that means is that you get a really good understanding of how to actually apply things to different areas and how to actually use them. Okay, so before we jump into how you should get started in data science, let me take a quick detour to talk about how I actually got started. So I actually have a BA in American history, and I didn't actually learn to code until about 4 years ago. So I was a US diplomat, and I wanted to make more of an impact on the world. I didn't feel like what I was doing really had a tangible impact on helping people. So I started learning using online resources, and I started learning machine learning, data science, and ended up winning a few machine learning competitions and eventually working at a few places as a machine learning engineer before founding DataQuest. So I'll kind of reference touch points along the way and things that really helped me as we go through this presentation. So the big problem, and I'm sure a big reason why a lot of you are watching this, is learning data science is this nebulous process that isn't really aligned with application. And what I mean by that is, one, it's unclear what data science even is. And two, it's unclear how to actually learn it. So where should I start? What should I do next? And often the resources that do exist don't actually emphasize application. So you may end up understanding a little bit, but you're unable to put everything together. You're unable to actually make the whole project or whole data science workflow. And this is a big problem, and we'll start to talk about how to break this apart and how to actually solve it. So what is data science, to answer the first question? So it's a very new term, and it's kind of this term that takes a lot of existing fields and kind of jumbles them together. And those fields are statistics, there's a little bit of machine learning, there's a bit of coding, there's a lot of communication, data visualization, and it's just kind of the intersection of a lot of these concepts. And this is kind of what makes it hard to tease apart. But what we're increasingly finding is that you're kind of seeing specialized roles within data science. So data engineer, data analyst, machine learning engineer, and there are a lot of components that make up data science, and how much you need to know in each of those areas varies for each of these roles. For example, a data engineer needs to be better at actually coding and making projects, whereas a data analyst needs to know less statistics and math and more visualization. And a machine learning engineer is more focused on software and machine learning. What we're going to talk about specifically in this presentation is how to become a data scientist. But it's important to understand that all these roles exist, and if one interests you more than the other, that should shape how you learn and what you learn. All right, so fundamentally, data science is about solving problems. And what does that mean? it really means that a data scientist's job is to find interesting insights and to communicate those interesting insights and to solve problems along the way. So a typical data scientist may be asked to figure out something like how many, if you're a data scientist for Yelp, you may be asked to figure out which restaurants are more likely to get more reviews, which restaurants are more likely to have certain characteristics. So it's about kind of being able to quickly decompose this problem into easily solvable steps and then actually solving those steps. And really the only way to learn how to do these is by doing them, right? I mean, it's hard for someone to explain to you over video, which is ironic because this is an explanation over video. It's really hard to teach those things unless you're actually doing them. And the reason for that is you actually need to be able to apply these skills on your own. And unless you can actually do them, it's hard to do that. All right, so really what this comes down to is in order to get an entry-level job in data science, there's kind of this myth as you go through data science education that you need to learn a lot of algorithms, you need to know a lot of specialized terminology, but really that's not super important. What's really important is that you have basic algorithm skills. And what I mean by basic algorithm skills is that you're pretty good at a few algorithms. So linear regression, logistic regression, and maybe k-nearest neighbors or k-means clustering. Those 3 or 4 are probably a really good place to start. But if you can actually understand them, talk about the trade-offs, talk about what works and what doesn't with each of those algorithms, and you can actually implement them and do a data-centric project with them, then you'll actually be much more employable than if you know a little bit about dozens of algorithms like k-nearest neighbors and tons of other things. So actually being able to do things, even if they're very basic, and understanding why those things work and how they work is much more important than just knowing a little bit about a lot of things. And unsurprisingly, a lot of a data scientist's work is just data cleaning. 90% of your work will actually be just manipulating data, figuring out how to clean it. And what I mean by data cleaning is a lot of the data sets you get in the real world are going to be very messy. So for example, if you get airline data, it's not going to be in a neat table showing this flight took off from here and here's when it landed. It'll probably be much more messy log data. Saying here's a flight number, maybe the flight number is missing, here's an airport code, here's where it landed. And you basically have to get from that data to something that enables you to easily answer a question. And it's a ton of work, it's really, really hard to learn, but it's something that people often skip over. And they jump over this whole data cleaning aspect and they jump into, oh, how do I do a linear regression? Or how do I learn this framework? And it's really, really critical to get those data cleaning skills. And part of application is also understanding the trade-offs. So if I make a bar chart, what does that mean? Why is it better or worse than a line chart? What are the cases when I should use one versus the other? These are really important things to understand. And really this knowledge, a lot of it just comes from doing it and kind of thinking through those trade-offs. All right, and it's a lot about communication. So you don't often think about this when you're learning data science. But a lot of data science work is just explaining your results to people. So it's kind of figuring out, hey, here's what I did, and here's why I did it, and here's some visualization. So it's telling a story, giving people justification for your story, and helping sell them on why they should make a business decision, or why they should change a process, or why something really, really is critical for them to pay attention to. So it's really important to develop these skills. And I'll talk about a few strategies for doing that later on in the presentation. And by the way, if anybody has questions while I'm talking, there is a Hangouts questions tool, so feel free to ask them. This is my first time using Hangouts on here. It's a little bit interesting. All right, so communication is critical. Systems are also critical. So this is something that's more important if you want to be a data engineer, but as a data scientist, especially as you deal with larger and larger data sets, you're going to have to write code that has to run quickly, has to scale to multiple machines when you're dealing with something like Hadoop or Spark. And it's really important to understand those systems, how they link together, why certain code runs faster than other code. So for instance, I've written code that took 1 or 2 days to run, and I needed to run it repeatedly. And that's obviously not a good performance characteristic. You need it to run much more quickly than that. So I made minor changes to my code, and it ended up getting down to about an hour. And it wasn't really the fact that the syntax of those changes was minor. It was understanding why making those changes would help and how it could help. And a lot of it had to do with the fact that I was nesting a lot of for loops and just doing really ugly data manipulation things. So understanding systems is actually pretty important. And the last one is just programming. This depends kind of where you want to work as a data scientist. If you want to work more in kind of the startup world, where you're putting things into practice much more quickly, it's actually really important to be able to write good code that you can easily push into production. The scenario you really don't want is, hey, I wrote code and now I'm going to put it in production and all of a sudden it fails. And this happens to a lot of data scientists because programming isn't really a skill that's emphasized as you're learning data science. But if you kind of want to be, if you want to be a data scientist who communicates reports and then someone else kind of runs and takes action based off those reports, being able to write well-structured code isn't as important. But on the other hand, if you want to be a data scientist that actually creates algorithms that directly impact consumers, or you want to be able to make a dashboard that helps a student learn better, programming is really, really important. So these are kind of the big areas to think about as you're learning data science. And now I'm going to kind of walk through how you can gain expertise in each of them. All right, so before we get into that, a quick detour on what not to do. So I worked at edX. I'm very familiar with MOOCs and lectures. And kind of the sad truth is they're good ways to casually pick up knowledge. They're really, really bad ways to learn skills that you want to apply. So I mean, if I wanted to get a job, I probably would not go through a lot of MOOCs to get there. I would take a few MOOCs, maybe supplement them with a lot of projects and a lot of outside learning. So MOOCs and lectures, they're very passive experiences. And this kind of ties into what not to do, videos. So videos are very passive. And this happened to me a lot when I was learning. It's really easy to be convinced that you're learning something when you watch a video, because videos are often very entertaining. A lot of MOOC videos are very well done. Some aren't, but that's a different story for another day. But when you're watching a video, you're actually not learning that much. It's not until you can actually write the code and do it yourself that you've actually learned a concept. So videos are kind of this insidious trap in that they can convince you that you've learned something when you haven't. So I would very much steer away from videos if at all possible while you're learning. What not to do, also syntax only. So it's really tempting when you want to do something quickly, when you want to acquire knowledge quickly, or you want to learn something really fast, to just kind of learn the syntax. And what I mean by this is we have lots of great data science tools. So we have pandas, scikit-learn in Python. We have random forest packages, linear regression packages in R. And all of these things do a lot of things for us automatically. And they make it so we don't really have to think about what's going on underneath the hood. But linear regression, for example, fails in a lot of cases. It fails when you have non-linearities in your data. It fails when you have a lot of high-dimensional data. It can fail in all these cases, but unless you really understand how linear regression works, you're never going to catch those cases, and you're never going to really be an effective data scientist. So it's really important to not just learn how to do things, but it's important to learn why you should do those things and how those things work. So, I mean, I can't emphasize this enough. Just reading kind of a workbook that says type in this command, and this is one of the reasons why I don't think things like learn Python the hard way are really good ways to learn, because they don't really give you that deep intuition of how something is working. And unless you kind of get to the core and you kind of get into it, that's really not going to be helpful to you as you go into your data science career. All right, so another thing, what not to do, and kind of ironic, but don't only follow guided tutorials. It's really, really critical to take off the training wheels, and it's really, really critical to keep pushing your boundaries and working on projects and kind of like pushing your comfort zone. So it's really easy to kind of like stick with guided tutorials and do exactly what someone's telling you to do and kind of like stay on this track. And that's good. It's actually a good way to learn for the first few months, and it actually teaches you a lot. But it's important to not get stuck doing those things forever. And this is something that I noticed when I was learning, which is basically if you keep, I see a question now, and I'll get to that soon, Arnold. Basically, if you keep doing these kind of guided tutorials, you're never going to learn how to do things on your own. So for example, in a real world data science workflow, when I was at edX, one day I was asked to figure out what students' grades were in courses. And we had this really ugly system that couldn't compute grades very quickly. It took basically 4 days to run the grades for a course, which is kind of insane, but it had to crawl through a big database. So I had to make a system that basically showed grades in real time. And how that was done was complex and so on, but that was 1 week. The next week was writing a machine learning algorithm to automatically grade students' essays. The next week was figuring out an algorithm to match students together when they were peer reviewing each other. So your work is going to change pretty rapidly, and you have to be ready to kind of go with that. And following guided tutorials won't really teach you how to quickly adjust to new situations. The only real way to do that is to make a lot of projects that deal with different aspects of data science. All right, another thing that I'd really caution not to do, and I made this mistake when I was learning, is don't focus on 3 or 4 languages. Pick one and go with it. And it almost doesn't matter which language you pick. And I say almost because I'm very biased towards learning Python. But I have a friend who's done a lot of great cutting edge machine learning work in Ruby, natural language processing work. Python is great because it has a lot of good data science packages, machine learning, data manipulation, and so on. And it's also widely used by a lot of companies. So Python is always a great skill to have. Other commonly used languages are R. Julia is starting to see some adoption, but not a ton. But really critical is just pick one and stick with it. I highly recommend Python because it's easy to learn and widely used. But really, it can come down to personal choice. All right, so now the big question, how do you gain all these skills? And I've talked a lot about what not to do, but now what should you do? And before I get into this, someone asked a question, what are the 4 important algorithms to learn? And those 4 were k-nearest neighbors, k-means clustering, linear regression, and logistic regression. And the reason for those 4 specifically is logistic regression is a classification algorithm, linear regression, obviously a regression algorithm, the most commonly used. K-means clustering is a clustering algorithm, so it'll let you pick up different kinds of groups and clusters in the data. And k-nearest neighbors is a really good regression or classification algorithm that can pick up nonlinearities in the data. So it can succeed in a lot of cases where linear algorithms can fail. And it's pretty simple to understand. All right, so step 1 when you're learning data science is learn to code. And there are a lot of great sites to get the very basics, things like Codecademy, DataQuest, etc. So get that very basic syntax out of the way, then actually learn kind of the deeper things. And a few ways to do this are go to programming meetups in your area. So I live in Boston. There are tons of great meetups here. There's project nights every month. Definitely go to those. It's really important to interact with other people to kind of get their perspective, to figure out how they're learning things, and just to build a network. It's really, really critical to have those people around you. Work on projects. So these projects you can find in a lot of places. So DataQuest has a lot of data sets, a lot of interesting projects you can get started with. There's also tons of data sets, and I'll get into where you can find some of those next slide. And then go to hackathons. So hackathons are actually a really good place, even if you don't really know much coding, to kind of like quickly figure out how to build a project from scratch. Highly recommend going to those. So learn to code, learn the syntax really quickly, then just kind of jump into working on projects on your own and with other people. And then step 2 is really learn to work with data. So once you have a basic understanding of coding, you can actually start parsing through data. And DataQuest has some examples of these, working with CSV files and so on pretty quickly after you've learned to code. So answer some questions about the data. And here's a few good sources of data. There's lots of good government data at census.gov and data.gov. The Reddit subreddit, our data sets, has a ton of good ones, including Jeopardy question data sets. Just lots of cool data to go through. They had a recent one that detailed all the prisoners who are currently incarcerated in Florida and their sentences, what they were sentenced for, and so on. There's also the UCI machine learning repository. This has a lot of data sets that are like very clean and easy to manipulate, so that may be a better starting point than the other ones, which tend to have data that's a bit messier. So answer some questions. So some interesting questions would be, from the Jeopardy data set, how long are the questions that people get right? Is there a difference in length between questions people get right and questions people get wrong? How can you determine which question is harder than other ones? Tons of interesting questions you could ask there. Government data the same way. Hey, maybe I can map out income, see which state has the highest income, things like that. Think about what you might predict. So I wouldn't jump into machine learning just yet. I'd focus really heavily on data cleaning, data manipulation, and so on. But think about like how you might predict something. Think about how, in the absence of something like linear regression, how you might figure out a state's income 10 years from now using census data. And go to data science meetups. There's tons of great data science meetups. If you can't find any, start your own. It's actually amazing how many people are interested in this and how many people will thank you and come to your meetup. So step 3 is start to work a little bit with machine learning. So this is things like get really familiar with linear regression, which is one of those 4 algorithms I mentioned before. Go to machine learning meetups and work on a project and keep increasing the scope of that project. So when I started learning, I picked predicting the stock market as my project. And I didn't know how to code. I didn't know any machine learning. I didn't know anything. But I started out just scraping data from Yahoo. They have next day stock price data. So I scraped that data. And then I was able to make really simple algorithms that kind of used weighted averages of stock prices to kind of quote unquote predict the next day's stock price. So I wasn't using any machine learning, but I was starting to think through how I might predict something, and I was starting to build a system. And then the next step was to actually add linear regression. And then I was able to use that. And the next step was to move to a more powerful algorithm. And the next step was to move to predicting things hour by hour instead of day by day, then minute by minute, then tick by tick, then using a lot more historical data to predict. So just keep adding these pieces to your project. Try to find an area that you can go pretty deep in, but can still be easily approached without knowing a ton. Stock price prediction is a really good way to do this. Another really good kind of area for this is like grammar correction, essay grading. I mean, you can start with very surface characteristics, like your words are too long, and then gradually get more and more complex. All right, so the next step is more application and some theory. So this is things like start getting your name out there. So write blog posts, speak at meetups, put projects on GitHub. So if you're trying to get a job, basically the number one thing, at least among startups and kind of progressive tech companies, the number one thing people will look at is your portfolio. And this is your kind of public presence. It's your blog, it's anything you have on GitHub, it's any websites you have live. It's just really, really important to do these. And as a friend of mine says, like you're never not ready to speak at a meetup. Like even if you know absolutely no coding, even if you're just learning, your talk can be valuable to someone. And it can help you a lot by making contacts, by kind of putting you on the map and so on. So definitely take advantage of these opportunities that are constantly around you. Writing my own blog actually really helped as I started my own consultancy. I got quite a few leads through my blog, and then later it helped me get a job and a lot of other things. And GitHub is just critical, both for practicing and for building a portfolio. It's the number one way developers judge other developers. It's just the quality of code on GitHub and just how much you have up there. So definitely don't neglect building your own portfolio. I can't emphasize that enough. And then this kind of leads you nicely into consulting. Once you have a portfolio, you've built all this up, you'll start to naturally get these consulting opportunities. And a surprising amount of these come through in-person networking at meetups. So after you talk, you'll be surprised at how many people you'll meet, and you'll be surprised at how many of those people you can consult for, and so on. So consulting is actually a really, really good way to work on a ton of projects very quickly. So you're essentially learning, but you're getting paid for learning, which is an awesome deal, right? It's just a really cool experience to get to work with so many data sets so quickly and just kind of gain the confidence and abilities. So consulting is a great way to kind of keep building your skills. All right, and around here is probably where you should know some statistics and linear algebra before this, just kind of the basics, but this is a good point to kind of start diving deeper into theory and like learning more advanced algorithms and getting a little more deep into them. So this is where the other 3 algorithms out of the 4 I mentioned come in. So this is where I'd learned more of the theory behind k-nearest neighbors, k-means, logistic regression. And then step 5, just keep getting better at coding. So this is an underrated aspect of data science. I mean, you never need to be the best coder in the world if your goal is to be a data scientist, but you need to be pretty good. And most data scientists are decent to good. So these are things like start writing unit tests, figure out how to automatically test your algorithms to make sure they're working. Learn some basic computer science skills. So why is writing a piece of code this way faster than writing it a different way? How can I implement the different sort and search algorithms? Try to refactor your code. So the #1 way to figure out if you're progressing as a data scientist, computer engineer, anything, is to look back on your work from 6 months ago and to see if your work now is better than that. And if it is, then you know you're improving. And if it's not, then maybe you've stagnated and it's time to kind of shift gears and try something else or challenge yourself a little bit more. So I constantly look back on my code from 6 months in the past, and I think, how was that? How did I even write that code? Why is it so terrible? And that's kind of where you want to get, to the point where you're constantly criticizing your past self. Not in a bad way, but in a way that just makes it clear that you're improving. Yeah, and then get better at the command line. So command line is a skill that a lot of data scientists need. Most have, some don't, but it's a really critical to develop skill. And this is kind of like a Linux skill or OS X skill. How do I work with the command line? How do I manipulate data on the command line with sed, awk, grep, other command line tools? And then step 6, just keep broadening the scope. As I mentioned with my stock price prediction program, just keep working on more projects and keep working on bigger and bigger scopes for those projects. This is the stage where if you wanted to learn some more algorithms like random forest, SVM, maybe neural nets and deep learning, this would be a good point to do that. Keep working on larger data sets. So work on data sets that don't fit in memory, that you need to scale to multiple machines to work on. Think about how you're going to store that. Think about how machines can be networked to get there. So just keep broadening the scope. All right, so how long should this take? And it's an interesting question because it's really different for everyone. It really depends how much time you have to dedicate to this. It really depends how quickly you want to learn and where you want to get to. So for me, it took me about 6 months to really get to like step 6 and be reasonably confident in my skills. Although when I got a job, I kept learning even more. So your learning is never done. But I also was doing it basically full time. I quit my job, so I just had time just to learn. If you're not doing that and you're doing it on your own part-time, it might take a year. It's not something that I would expect to kind of get a handle on very, very quickly and be able to get a job with very, very quickly. These are skills that just take a while to acquire and learn, a lot of motivation. I think anyone can do it, and I think the fact that you're already watching this means that you definitely can do it and you have the motivation to do it. Just don't get frustrated if these things don't click overnight. These are some advanced concepts, and they definitely take some time to sink in, and it takes time to kind of be able to work on lots of different projects and with lots of different data sets. There's also the notion that the field is changing very quickly. Spark, which is a very commonly used big data tool, didn't exist a few years ago. So we're constantly adding new tools. It's important to constantly stay on top of this. So that's definitely part of this constant learning that you need to do as a data scientist. All right, so that's kind of it for the main part of this presentation. I'd love to take questions now, but right before I finish, I want to talk a little bit about how DataQuest can help you. So DataQuest, dataquest.io, which I founded, teaches fundamentals and not just syntax. We kind of teach you how to think about problems, the theory behind what you're doing before you learn the easy, nice syntax to do it. And we focus a lot on real-world data sets. So we teach, for example, Unicode, a computer science concept, I guess you'd call it, by going through a CIA sentences data set. We use an NBA data set to teach a lot of other concepts. So it's really important to get that real-world data set experience, and we help you do that. We're also adding in mentorship features. So you can live connect with mentors and kind of get guidance on a weekly basis. And we're adding in the ability to work on projects. So after you've gone through these guided tutorials, what do you do next? Maybe you work on a project for your portfolio. We can help you get there. All right, so that's it for me. I'm very, very confident that all of you can learn this. There's nothing magic. Just kind of climb that mountain, keep working on projects, and I'm confident you can do it. And if you have any questions, my email is vic@dataquest.io. And if you have any questions right now, please put them in the questions box and I'll answer them. Otherwise, have a great rest of the day. All right, I don't see anyone asking questions, so I guess that's it. Thanks for joining me, and have a great rest of the day.